Here's a quick review of how to use the Q-test template that we created last semester. Uh, here, you'll notice in columns A through D, you don't mess with this column. This is a preset. This is just a column of critical Q values for Dixon's Q-test at 90%, 95%, and 99% confidence interval for different number of trials. Okay. And here in column F and G, this is where you actually enter your data. You put your trial number here and your data for each trial. Now, you'll notice here, this thing is already sorted from lowest to highest. You sort it from lowest to highest if you're trying to see if the lowest number can be thrown out using the Q-test. And the way you would sort your data, let me just sort this back to the original way it was entered. You highlight these. So that's 10 trials. So you go data, sort, and then you sort by, in this case, column F if you want. You don't have any headers. So you want to sort by column F from smallest to largest. So that would make it columns trials 1 through 10. Click OK. You'll notice, okay, trial 1 is 0.189, and your lowest number actually is trial 2. So now if you want to check whether or not the lowest number here, 0.150, can be rejected using Q-test, you have to sort this so that the lowest number is in the first row. So you sort by column G instead from smallest to largest. Okay. Now, if you want to test whether this largest number, 0.189, can be rejected, notice here the largest value is trial value is 0.189, then you sort it in increasing values. So sort by column G from largest to smallest. Okay. So let me just sort this back from smallest to largest. I want to check whether 0.150 can actually be rejected. So sort column G from smallest to largest. So if you do this, the formulas entered here are automatically updated. The values would automatically updated. And in this particular case, 0.150, the result is you can reject it at 95% confidence. So let's just examine these formulas right here so you remember what these mean. This 10 right here, formula for that, it just counts the number of data points. So all those blank points, blank cells right there are not counted. It's only counting 10 data points. Like if I were to take this one out, you notice that changes to a 9. Let me undo what I just did. Okay. This formula right here just gets the minimum of all these numbers. Regardless of whether the numbers are sorted, it will pick up the minimum value. Okay. And this is the maximum value of all the numbers that are tabulated. You notice it should be 0.189. Now, let me resort this again so you can see that this would stay at 0.150 and 0.189. So if I click sort from largest to smallest, it's still 0.150 and 0.189. If I sort by column F from smallest to largest, you can see the smallest is column row number, the second trial number 2 is 0.150, and 0.189 is trial 1. That's the maximum value. So let me resort this so that I get column G from smallest to largest. So 0.150 is minimum, the maximum value is 0.189. The formula for that is just max, open parenthesis, and cells G2 through G31. Okay. The range is just the highest value minus the lowest value. So that's J4 minus J3. Okay, so it's not going to change whether you sort or not. The closest to the potential outlier is the second row here. So that's row number 3, actually, second row for your data, because This is your potential outlier. You sort it so your potential outlier is out up here at the very top. And then the row next to it is where the data that is closest to the potential outlier. So this one is just that cell right there. So it's 0.177. So the gap to the potential outlier will just be, well, the difference between the top two rows, the experimental values between the first two rows. And you take an absolute value, okay? And then the Q value is defined as the gap to the potential outlier divided by the range. So it's 0.027 divided by 0.039, J8 over J5 on this sheet. And here you just have a pull down menu. I've had it set up so you can just pick 90, 95, or 99% because you only have these three possible choices for your Q-test for the critical values that I have tabulated here. So you can, by default, you can, if this goes to 0.95, you can change it to any 0.9 or 0.99. The column number, this is the column in the table that has a critical value for the selected confidence level. So if your selected confidence level is 0.95, 95% confidence, then the column number where those critical Q values are found is column 3. There's column 1, column 2, column 3. So column 3 is column C. That's where 95% confidence level, the critical Q values are for 95% confidence level. If you select this to be 0.9, for example, then column number for the critical Q values is column 2, column 1, column 2. So it's column 2 in the table is 90% confidence interval. Okay, so this is just an if statement. If J10 is 0.9, it's column 2. If J10 is 0.95, it's column 3. Otherwise, it's column 4. All right, so Q critical. This is where you use the VLOOKUP function of Excel. This the first entry here is the lookup value. You look for the number of trials in column 1. Okay, so J2 is the number that you look for in column 1. Okay, so we're going to look for the number of trials here, and the number of trials is 10 for this particular data set that we have. Okay, so you notice your first entry here in the formula is J2. If you look for J2, which is the number 10, in the table of which is A3 to D30. Okay, so our table of Q values is A3 through D30. Okay, and then J11, this is the column number from the table where you look for the value. So let's see. J2 is 10. So it says look for the number 10 in column 1. Okay. So what this is saying is look for the number 10 in column 1. So here's number 10. Okay. And then look at this table, right? And then look for J11, which is column 2. So look for the number 10 and look for column 2, column 1, column 1, column 2. So the number that you find is 0.412. See, if I change this to 0.49, 0.95, 95% confidence level, then the number 10 in row 1 corresponds for column 3 would be 1, 2, 3. The third row is 0.466, 0.466. And in this particular case, you reject the lowest value. Okay.